Hi, my name's Gary Taylor, and in this video I want to walk through redelivery and retries within exceptions. So mass transit is a transport layer to allow messages to be queued. Um, it controls the way that messages can be pushed onto exchanges, and it has some great features that allow us to detect errors, detect exceptions, to move messages to like an underscore error queue, and it also allows the mechanism of retry. Now, in a previous video, pinging up at the top right now, we discussed how to actually do retries and how to manage exceptions. So check out that video before you watch this one. One of the things I came across as I was looking at this documentation is that we're talking about retries and exception handling and things like that, and just retrying maybe 5 minutes later. But then we start talking about scheduling with redelivery. Now it shows here that, some errors may take a while, some servers need to be restarted, or you might have some planned maintenance where there's no point delivering messages for the next hour because that part of the system's under maintenance. So you might as well just hold on to them. No point trying to deliver them to the consumer, maybe. And there's an argument there that, what is it are you trying to achieve here? Because if the consumer's not available, then the consumer could be switched off, and therefore messages would flow through into the queue and just would wait there indefinitely, or based off whatever transport layer configuration you've got. Some systems messages are deleted after 4 days, but if you had a service down for 4 days, you've got bigger problems than that. So with this, we're talking about redelivering at a later date. But in some situations, you may have a microservice architecture, you might have a platform like Kubernetes, and you could be large scale. You could have a couple of thousand consumers all managing load. Well, you don't want messages to be delivered to them consumers. You simply don't want the message to hit the queue at all. Well, in that case, what you can do is you can use a scheduled delivery. So messages don't even hit the queue, which is I found really interesting. Um, Up until that point, I thought messages had to live in a queue, otherwise they were dead. They were not deliverable. But it turns out that's not the case. So great, we've learned something. We can see that messages can actually be held at the exchange level and then delivered to the queue at a particular time. Now, this idea gets my brain thinking because what if we wanted to send an email to a customer at 6 p.m. tonight? What if we had some schedule where we wanted to do a particular action at a particular time? We've got cron jobs that run every whatever time period and do a particular action. Well, with an event-driven system, I don't like the idea that consumers have code in them to determine when they should be delivered. It just doesn't feel right to me to have consumers fire up at particular intervals. So using a schedule redelivery, really, I like that idea. Where I can say, do you know what? Don't deliver this now. It's 120 minutes until 6 o'clock tonight, and I want this delivered at 6 o'clock tonight. So schedule the redelivery for 120, 160, whatever minutes it is, and when it hits that time, the exchange will actually process that message and push it through. And I think it's wise to note that this is not really mass transit that's doing the redelivery. This is a feature of the transport layer. So whether it is mass transit or Kafka or whatever, it's that layer that's actually responsible for scheduling and redelivering. So if we have a look at the extended documentation, we can see we configure mass transit is going through a service layer. So we're setting up a service. We add a consumer, and using RabbitMQ, we're going to schedule a message, and we're going to set the endpoint there. and we're going to configure then the endpoint context. And at this point, the message will come through, we'll receive it, we'll get the delivery time, and that's it. Now from here, from the bus layer, where we're actually going to be publishing the message, it's the publisher that actually denotes when, how long to hold that message for. In other words, when to schedule it. And it appears to be a retry from now, or republish or resend from now. So in most schedulers, you would say do this at 6 o'clock. What you've got to do is work out what is 6 o'clock from now. So here we're looking at time now, and then we're adding on 30 seconds. So this will be delivered, well, the exchange will deliver this to the queue in 30 seconds from the date it's been sent. And we're able to increment things like cron job times or our recurring message redelivery. So let's dive on this and let's see if we can create a scheduler. So here we've got an example of a consumer, and here we've got an example of a publisher. I'm going to do what I hate. I'm actually going to consume this and do it in one service, because it is harder work and it takes a bit more code just to write two separate services. And I think from all the other videos I've been doing now, I've kind of proven the point that they are separate and can be separate and probably should be separate services. So let's dive over to some code. So I'm going to do a new project, just a console app, .NET New Console, MassTransit Scheduler. Looks different than usual. Okay, just looks slightly different. Okay, brilliant. So I've got that. Now let's get the MassTransit goodness installed. Awesome. .NET build. Should build because it's brand new, but I always do it just in cases. So I know there's problems because of what I've just done, not what was. Let's open it up in the current window. Open up my terminal. I get a PowerShell terminal. Yuck. Change to Git. I'll work out how to change my default shell. Okie dokie. Got a nice main. So let's dive over to here and let's copy and paste. We should never copy and paste because we misunderstand things. So if we've got a service collection, we're creating an endpoint which is going to be a queue to a thing called scheduler. We're setting up MassTransit. We're going to add message scheduler, and we're going to add a consumer and use RabbitMQ. So of course we need the consumer. Then using RabbitMQ, we're going to use a message scheduler, and we're going to configure the endpoint context. One thing I'm not quite sure of is why would the consumer need to understand the scheduling? Why would it need to use a scheduler? Because it isn't responsible for scheduling it. It's the exchange. So I don't really understand that. So let's grab the remaining consumer. Okay. I don't like it when it goes under. Come on, keyboard. Oh, this is all got a bit pear-shaped, I think. code. It's, what's going on here? So apologies for that. I just pasted it in just one below the class. I pasted it in the program class where it should obviously be a separate class. Let's just do .NET build just to make sure. Type consume context could not be found. Okay, so no squigglies, no errors. Let's give it a reload. There we go. Code's coming back to life now. So of course we've got the using statements. We're going to need threading as well. Didn't think we need, using services, so maybe services needs the dependency injection. Okie dokie. Microsoft extensions, dependency injection. Just going to comment that out. Do a build. So service collection, yeah, service collection must be part of the dependency injection because it's the services that you inject everything into. So it kind of makes sense. So let's install that. Then add MassTransit. So where do you live? So okay, add MassTransit. Well, I thought add MassTransit was actually part of MassTransit. So by including MassTransit, I would automatically get this extension method. Can't F12 into it because it's not declared. Am I getting errors, or is this just another one of Visual Studio Code? Oh, let's reload again. So this is obviously a problem with my machine and the way that Visual Studio Code's working. This is nothing to do with Rabbit. It's just the way that I'm hot loading in dependencies whilst I'm coding at the same time. It's too much for the little thing to handle. So yeah, we're building, we're okay. Oh no, we're not. No, we're not. It's still erroring. Jeez. Oh, I know what this is. It's dependency injection, but it's MassTransit's dependency injection, isn't it? Numbnut. Right, okay. Add MassTransit is obviously a dependency injection from MassTransit, but it's not under the MassTransit namespace. It's under the dependency namespace, which would be this. Obviously, I could have just copied and pasted all of the dependencies in that I do in all the projects, but what I want to do is understand what is needed when. I've seen some projects with 30 DLL NuGet packages included and some rogue DLLs added in as libs. And when you actually look at it, only a handful of them actually being used by the code. And sometimes there's using statements all over the place where the using statements aren't even needed. And it is a real pet hate of mine that code should only have what is needed to run. And if you were playing about with something, get rid of it. Anyway, I rant. So now let's do a build. We should be okay now. Doesn't appear to be any errors. So what have we got? We've got MassTransit, we've got a scheduler that we're going to configure. We're going to add a consumer. This consumer is going to take that message and what's it going to do? It's going to schedule send it. So it's going to send it then to notification service, and that's going to deliver it at a certain delivery time. And then that is it. Okay, so what about the rest of the code? Consumer, and then from the bus. So this is going to be a separate part, which is configuring then the publisher. Am I right? Yes. So this sets up MassTransit, and then we get a publisher, and we send it out using a schedule publish. So this basically is going to read that queue, go to there, and then this is going to send it out again on a notification. Bit too much just for an example. I mean, Jesus, I'm already bored. So that on its own won't do anything because we don't have any message that's been sent to that. So from here, this is the same code, I think. A scheduler, schedule endpoint. Same boilerplate configuration code to use the scheduler. Configure. Yeah, I mean, if I overlap it and I'm going backwards and forwards, you can see code's hardly changed. So here, what we're doing is we're going to get a provider, get required services, and schedule. However, yeah, that should work. If I just take this code here and push this down at the bottom, public static, make it async so that the 808 doesn't go crackers. And no warnings. So what we should do is be able to set up a consumer, then set up the producer to send the message. That's going to send it from 30 seconds from now. It's going to go to send notification, of which we don't have any endpoint for send notification. We have a scheduler, which is schedule notification consumer. And schedule notification consumer uses schedule notification. Okay, but that's send notification, so that won't work. None of it will work. So the example's not fit for purpose. Okie dokie. Right. So let's build it. Just make sure it builds. Let's give it a run. Let's see what we win on the queue. So if I go over, I can see the scheduler. Looks like a message was actually pushed to the scheduler. And if I go to the queue, here's a scheduler with one message in it. So if I get the message, I can see this was an email message, scheduled time of it being delivered. So yeah, 9:32, which was like a minute or so after it was sent. Let's see if I can back that claim up. There should be a date. So if I look at 21:21, time sent 31:40, 32. So it's like what? What was that? Yeah, so yeah, be about 30 seconds, 29 seconds. It's not perfect, by the way. It isn't gonna be to the millisecond. It's scheduling the system. There's time to deliver, time to wake up, and time to process. But it looked like that message was successfully put onto the exchange and then passed through to the queue. So let's see if I can run that again. And let's dive to that. What we should see is the scheduler waking up. So message right in, and then that should then be passed through to the queue, and it's in. So let me run that again, and what I'll do is I'll show you the queue. So if I run the queue, you can see there's no message in the queue, still at 2. And yeah, I know it doesn't refresh all the time, but just trust me, it's not in there. Then now it's 3. So it didn't go into the queue and get held in the queue for 30 seconds and then made it available. It actually stayed in the exchange for 30 seconds. Then after 30 seconds, it was delivered through into the queue. So let's see if I can fix the consumer, because I don't know why this is all talking about the wrong different stuff. So send notification on a publish. Well, there's no consumer set up, and therefore there's no exchange and there's no queue. So because of that exchange, there's no send notification and there's no queue. So because publish doesn't do that, only send will do that. So how do we make this a real boy? Okay, so schedule notification consumer. Well, that's not even firing right. So what I'm going to do is just change this, I think. To send notification consumer. So let's see if I can use that send notification consumer. I'm going to get rid of the scheduled one, because this, right, okay. Scheduled notice consumer is the thing that's going to be sending the actual real scheduled send. What does that scheduled publish? And then that scheduled send. Oh, it's just showing the differences. Okay. So scheduled publish, got the interface, which will connect to the appropriate endpoint. We've got the time and then a body. With schedule, we've got a notification service endpoint, because obviously send will configure and set up everything. So that's showing us the differences between publish and send. Well, do you know what? I actually want to have this configured and set up. So what I want to be able to do is actually send from here. So if I take this and change this publish to be send, because I don't want to be configuring and setting this up by hand at the moment. It's too much. Which is a send notification. Send notification service. Schedule send. We're going to need send notification service endpoint, because I think it takes an endpoint, doesn't it, as a parameter. Let's have a look at, yeah, send. Then the first parameter is the send notification endpoint, because it's now send is going to actually configure everything. If I just give that a build, see if I can show you what I mean. In fact, if I run it, if I go over to a queue, that's not going to run because it's not even been hit. No, it is, should be. Send, we should use that queue. Okie dokie. Okay, so I've done this about 20 times now. So, example didn't show anything about actually starting the bus, but it kind of makes sense that we need to. So if I'm just gonna create the bus and start it. Now, obviously, I should wrap that and try catch and fail it and went and finally and stop it. But for now, I'm just playing, and there you go. So send notifications. We've got the scheduler now. Do we have a queue for that? We do. I'm just going to go into the scheduler now and purge that, so that everything's clean. So now that I've set up this send notification consumer, we have a message that's been scheduled and pushed out to send notification. When that happens, I was expecting the send notification consumer to read it. However, because the program is closing straight away, the consumer's not running. But I didn't see the message going into the send notification after a certain amount of time, which I should have seen even if the consumer wasn't running or the program wasn't running, because that's the responsibility of the exchange, I believe. Right, okay, so let's see what's happening. Let's write all that in your try catch. Let's create a property out of this. Generate field property. Generate local. No. Generate field. Okie pokey. So that should be okay. Let's see what we can get now. So we're going to run, and then it's going to wait for some input for me to finish. That allows the consumer to continue running. Got exchange, which sends notifications to the scheduler. That went to the scheduler, and obviously nothing went to send notification. So I was expecting that to go to the actual send notification, but don't forget we've got a scheduler here, and that's how we're actually sending it out. Okay, let me change that back to publish, because I think that's really what it should be. Yeah, and then obviously we have to change it all because it doesn't need the endpoint. We don't need that. So let's set up the send notification, which we've got there as the consumer. So if we have a look at the queue now, actually what we've got is MassTransit send notification. That goes to send notification. So one kind of uses the interface and one doesn't. That's probably just luck of the draw, I think, because of the way I've set it up wrong. So message come through there. So let's manually configure this endpoint then. What I want is I want to configure this endpoint, so I need it in the configuration section of Rabbit. Here, and it seems to be that it's under that. I don't need retry because I've copied that from the previous example that I did. That I had retry in, and that's not the point of this video. So okay, we have the consumer configured for the send notification endpoint, which should read that, but nothing's really going in there yet. So we have schedule publish, which goes to send notification. Then it's scheduled notification, isn't it? That we're trying to do now. Because I'm going to isolate tip with this. Okay, so if I look at this, because I'm using publish, I'm using the interface. I think that's going to use the namespace. So it's going to use something like MT schedule semicolon. So namespace. I spelled that right. I think I've spelled that wrong. That looks okay. And send notification. And then we're going to publish using that. So let's see what happens. Let's tear down this queue, because I might have to set it up manually if we're not using send. Exchange. Bind that. Queue. Delete that. Exchange. You're gonna get it right, Robin. Gonna keep doing this all day. Okay, is it still running? It is. Silly me. Okay, dokie. Let's delete this exchange. Let's delete that one. Let's delete this queue. And I don't think we need this scheduler. I don't know what type of design pattern they were trying to use in the example, but it's not needed. If I had maybe 1,000 IQ points on and read it about 40,000 times, I might get what the hell he's trying to say, but at the moment, no. So I've updated this to use namespace and queue or endpoint, so it's going to set it up with that naming convention. Publish is going to use that naming convention, but because I'm using publish, it won't actually set it up, because I don't think publish actually configures anything. Oh, does. And I spelt it wrong. NT, oh, honestly. So let's stop that. Let's clean up. Oh, the scheduler still. Why is that still there? What's going on? Okay, I don't want this scheduler. I think it's just confusing everything. Don't want you. Don't want you. Don't even understand why you're there. Okay. Let's run. Let's see what we get. I'm not expecting this to work now. So no service because it needs an iMessage scheduler. Right, okay. So I think if I configure Rabbit to use the delayed scheduler, then I don't need to set up the iMessage scheduler. I can just use the one built in. So no service has been registered. Okay. So using the delayed scheduler, for Rabbit and for MassTransit, we need to add a delayed scheduler, I think. So if we run that, we should have the service and then we should have the scheduler. Okay. So if we got now, got send notification exchange. Then we've got a queue with send notification. We didn't seem to process that though, did we? Just wait a little bit. So that should send it through, and it looked like it did. It looked like it sent a message through. Oh, and it came in. Right, brilliant. So tried to simplify this a little bit. So let's give this another go, shall we? If I run this, we should be able to wait 30 seconds or so. The message is going to be sent, but it's going to be queued. It's going to be held in the exchange, and then it's going to be redelivered to the appropriate queue once a particular delay has expired. And here we go. I paused the video obviously because I don't want to wait 30 seconds. No, neither do you. So at that point, we came in at just under 30 seconds, and if I look at the consumer, I was able to look at the X delay, and that's the bit that indicates how long it's been delayed for, and we can just output the body in a normal consumer. Now, there's nothing special about this consumer. It doesn't know that the message has been delayed, but it is able to work that out should it need to by looking at the transport header and get the value when we can get the value out of the message. So if I send another one pretty sharpish, let's have a look at the queue. So yeah, that will be delivered. In fact, if I turn this off now before it arrives, what we should find is it arrives anyway. And perfect, as I'd expected, the message was delivered even though the consumer wasn't running. The message was still delivered, and don't forget that nothing was running, the publisher or the consumer, so it's not like a service was holding on to it. In our managed code, it's actually being handled now within the exchange. So as soon as you've published a message and say, send this scheduled or publish this scheduled, it's the exchange then that takes care of that. My guess at the moment is it moves it to this underscore delay and then moves it back. That's my current guess. But if we look at the message itself, because it was sent using a different mechanism, it was sent using the scheduled publish. Well, this scheduled publisher is going to wrap it in a different type of message body. It's just going to have a different convention, a different syntax. If we get that message, we should be able to see things like the publish, the X delivery, and that's when it's scheduled to be delivered. And this is really good because it means that we can actually get that in the consumer. Now, just be careful. I want to give a shout out again to Fatboy G, who's obviously amazing and comes back instantly on the chat. I was trying to find that value within the headers and just couldn't find it anywhere. And it turns out that it's actually in the properties of the message, not the payload of the body of the message. Obviously, this is the payload, but there are these extra things that are part of properties, which are part of the actual direct message itself. And if you want to grab that data, You can do that with content received, transport headers, and then get. Transport headers is then the array of these properties here, I believe. So I was able to get the X delay, and then I'm able to obviously echo that out onto the screen. So the consumer has got the ability to work out whether the message was a scheduled message, should it need to, and I think that convention is really nice. Now, to finish off, I think it's vitally important that I didn't get this demo working. I didn't get this working at all. Well, if we have a look at the actual demo, if we look at, say, schedule notification consumer, this adds this consumer here, and this will consume a message of schedule notification. Well, there's nothing publishing that message in this example. And I know it's trivial to do that, but this example won't work. Copied and pasted. There's bits missing. If I have a look at, say, send notification, we have a, a send schedule notification, so it shows us how to use the send convention. We have a publish, so we know how to do the publish, but there's no consumer. So there's nothing actually reading this. We're also configuring a scheduler by hand. So what we're doing here is we're setting up a scheduler by hand. We're going to register it as a new scheduler, and then we're going to set the schedule up. So that is the scheduler, that's the service, and that's it being registered to configure under RabbitMQ. This is the same, but I have just used the shortcuts, the nice syntactical sugar and predefined things that we have in MassTransit to add the service and then add it to MassTransit. And instead of having a single exchange and single queue that's handling particular um, that particular scheduler, what happens is it does this underscore syntax and creates this delay, which is up to you. If you only want one exchange that deals with all delayed messages, all scheduled messages, then that's fine. Do that. However, I do like this notation. I like this syntax. I'm a big fan of MassTransit's design principles in the way that it builds these things for you, but allows you to tinker with them and tweak them to your liking. But I just find that the default conventions are just beautiful, so let's use them. And to wrap this video up, I think it's prudent to mention that none of this would work without the transport layer, this being RabbitMQ at our side, having the ability to understand how to schedule them messages. And that doesn't come generally for free. You have to put a plugin into the system that allows RabbitMQ to actually understand the how to deal with these types of messages and how to actually schedule them. The Docker instance that I had, where I am just configuring Docker by running the RabbitMQ3 management tool, that gets Docker up and running. It gives the IPs, sorry, it gives me the ports, sorry, and I'm able to get RabbitMQ up and running really quickly. That did not come with this plugin built in. So I had a look through the scheduling with RabbitMQ website, link here, and I also downloaded the latest plugin from GitHub, and using some command line arguments, I was able to update the system, get wget because it wasn't installed in that container. Sorry about that. And then I was able to use wget to actually download the plugin. And then finally, the command to get that installed and running. I believe there are containers out there on Docker Hub that allows you to download RabbitMQ and have a container that's already got the message exchange plugin built in. So just have a look for that. But if you've run through these examples and it simply isn't working, Remember, double check that your actual transport layer does support these message exchange delay configuration, and it is generally a plugin even with other services like Kafka. So that wraps up really. We had a look at the scheduled redeliveries. We looked at configuring, setting up the endpoint. I didn't really ever get this to work. However, I kind of understand the process. So then I use the general convention that we've got, where we just use a delayed message scheduler and add the service, and that just works perfectly. We're able to send a message but specify a particular time, so time from minutes, time from hours. And this is really good when you're wanting to deliver something at a very later date. You know, you're wanting this to go maybe in an hour's time, and that's difficult to hold that type of logic in your own context, in your own code. You know, what do? You just store it to a file somewhere and then have some cron job that reads it and pushes it through. um, Having this as an actual built-in mechanic of RabbitMQ and MassTransit, I think is beautiful. It allows us then to just publish these messages and say, right, today I want you to send one at 2, 3, 4, 5 o'clock. Close the program down and forget about it. That's it. Them consumers are going to get that message at that point in time and they're going to do their thing. If they have retry policies on them, then even better. It fails, it will try again, fails, tries again. And at that point, you could actually say, right, it's failed, retry again tomorrow at 4 o'clock with a scheduled retry. And that means that a delayed retry will then be held in its delay queue and will actually work its way through. And that process then will be forever, right? You know, if the consumer drops it in and says, right, schedule retry in not scheduled retry, sorry, just scheduled publish in 24 hours, then that means that this program is going to run every 24 hours because it runs, it then says, right, I'll do this same job again. And you get this really nice cron job type ecosystem pretty much for free and in C# code that's managed and understood by your team, which is a great strength. Instead of maybe some Azure scheduled service or some other Linux cron job that's running that nobody knows where it is and nobody knows how to manage it. This can be done with your same hammer. The whole consumer producer RabbitMQ MassTransit type goodness can be used to solve yet another business complex problem, and I love that.